format LPP, right? So first you see the question. A resourceful home decorator manufactures two types of lamps, say A and B, means type A and type B, right? So both lamps go through two technicians, first a cutter and second a finisher. Lamp A requires 2 hours of the cutter's time and 1 hour of the finisher's time. Lamp B requires 1 hour of cutters and 2 hours of finisher's time. The cutter has 104 hours and finishers 76 hours of time available each month. On one lamp is rupees 6 and one lamp B is 11. Assuming that he can sell all that he produces, how many E type of lamps should be manufactured to obtain the best return? First, here what? First, our aim to find out formulation means a linear programming problem, and then after this we solve and find out the values of x1 and x2 and substitute this one in z, right? All of you, first of all of you see here the objective function is what, right? So objective function here given, you see profit on one lamp A is here given 6 and another lamp B is 11. So here mention profit. So our problem is a maximization problem, right? So maximization problem. So if you consider here the decorator manufacture X1 lamp of type A and X2 lamp of type B, our profit will be what? For one lamp here, 6 rupees, right? So here X1 lamp, this one will be 6 X1. Similarly, for lamp of type B, here profit is rupees 11. So X2 type of lamp of B will be what? 11 into x2, and total profit will be what? Sum of this 6x1 plus 11x2. So this is our maximization, means max z will be 6x1 plus 11x2, right? Next, what here? Next, you see cutter required time what? For x1 lamp of type A require how many times, and cutter B we consider x2. So how many times requires? So lamp A requires, for preparing lamp A, it requires 2 hours of the cutter's time and 1 hour of the finisher's time. So for here two decorator we consider cutter and finisher. So x1 for the lamp x1 type of A, this one will be 2x1 because 2 hours, and type of B here require x2. So this is 1 into x2. So total will be, total time required for the cutter will be twice x1 plus x2, right? And you see here there is some restriction. Cutter requires how many hours for each month? So here you see cutter has 104 hours given and finisher 76 hours. So here maximum will be 104 for the cutter. So total will be what? Either 104 or less. So 2x1 plus x2 will be less than or equal to 104. Similarly, for finisher used in preparing x1 lamp of type A and x2 type of B require how many hours time required? So you see lamp B requires 1 hour of cutters and 2 hours of finishers. So here x1 plus twice x2, and this one need how many hours for each month? 76. So less than or equal to 76. Maximum 76 or less. So this is less than or equal to. So hence the decorator problem is find x1 and x2 which is maximized because this is the profit. So this one will be z equal to maximize z equal to 6x1 plus 11x2 and subject to constraint we already calculate. Constraints are what for cutter and finishers. So cutter one will be twice x1 plus x2 less than or equal to 104 and finisher will be x1 plus twice x2 less than or equal to 76 and here x1 be the what number of type of lamp A and x2 be the number of type of lamp B. So this cannot be negative. So x1 greater than or equal to 0, x2 greater than or equal to. And after this, you solve this one by you using either graphical method or simplex method. You solve and find out the values of x1, x2, and this is the solution. Means here, assume that he can sell all that he produces. How many of each type of lamp should be manufactured to obtain the best return? So finally, after solving this, you will get the value of x1 and x2. So this is up to the formulation, how to formulate. So clear this one? Nihal, Arbas, Ishita. This is the problem how to formulate the linear programming problem. And next one, second question is what? A farm can produce, not fun. Second question I have given. Yes. A farm can produce what is the you say second question is you says produce three types of clothes say A, B and C. Three kinds of wool are required for it say red wool, green wool and blue wool. 1 unit length of type A cloth needs 2 yards of red wool and 3 yards of blue wool. And 1 unit length of type B cloth needs 3 yards of red wool, 2 yards of green wool, and 2 yards of blue wool. And 1 unit length of type C cloth needs 5 yards of green wool, 4 yards of blue wool. The farm has only a stock of 8 yards of red wool, 10 yards of green wool, and 5 yards of blue wool. That it is assumed that the income obtained from 1 unit length of type A cloth is rupees 3, of type B cloth is rupees 5, and type C cloth is rupees 4. So determine how the farm should be use available material so as to maximize the income from the finished cloth. So from here you see first one is what farm produces here type of clothes are. Second question you see here type of clothes are A, B, C. Right? So if you consider the farm produces X1, X2 and X3 years of the three types of cloth, right? And next first we check whether this one is maximization problem or minimization, but here already mentioned here maximization problem, right? So here maximization problem given already mentioned maximize the income. So here you see kind of wools are what kinds of wools are red, green, and blue, right? Red, green, and blue. And here types of cloth are A, B, C, right? So in type A, here you see for type A, red wool for unit length, red wool require 2 and green wool is absent 0 and blue wool will be 3. Similarly, for cloth B, for making unit length of red wool, preparing red wool will be 3, green wool 2 and blue will be 2. And similarly for cloth C, here green wool is 5, red wool is no red wool, so 0 and blue wool is 4, right? Next here you see total profit is what? So total profit here given for unit length of type A cloth is rupees 3, then of type B cloth is rupees 5, C cloth is rupees 4. So this one will be 3x1 if you consider x1, x2, x3 years of 3 types of cloth A, B, C. So this is 3x1 for unit cloth require profit is 3. So x1 cloth, this is 3x1. Then for cloth B, this is profit is 5 for per unit. So x2 will be 5x2. Similarly for C, profit is 4. So x3 type of this one will be 4x3. So total will be Z equal to 3x1 plus 5x2 plus 4x3. And this is maximized Z. Max Z equal to this. Therefore, here next we need constraint. So constraints are what? So here you see constraints are total quantity of red wool required to prepare x1, x2, x3 years of the cloth of type ABC. And how many years required? So this is for 2, 3, like this here, 2 years and 3 years like this. Okay, so this one will be 2x1 plus 3x2 and no here 2 years and 3 years. So 2x1 plus 3x2 and x3, this is 0 into x3. Therefore, stock of red wool will be available only 8 years. So this is 2x1 plus 3x2 less than or equal to 8. You can write 0 into x3, no problem. Similarly, total quantity of green wool required is 0 into x1 plus twice x2, then 5x3 less than or equal to 10. And total quantity of blue will be 3x1 plus twice x2 plus 4x3. So this is less than or equal to 15. So hence the formulation of the linear programming problem will be here maximize Z. So 3x1 plus 5x2 plus 4x3 and subject to constraint will be all the 3 constraint you write and here x1 and x2 and x3 greater than or equal to 0 because x1, x2 is the years of 3 types of cloth. So this unit cannot be negative, so greater than or equal to 0. So this is the formulation of the problem. And after this, you can solve this. And this problem, if you want to solve this, so which method we shall apply here? Which method? Arif? method to find the values of x1, x2, x3. বুঝতে পারছেন আরিফ?
Yes, sir.
So, sir.
So in this way we solve. If formulation, sometime ask question, formulate the linear programming problem, or sometime is profit, means determine. Here suppose for this question, determine how the farm should use the available material so as to maximize the income from the finished goods. So in this way we solve the problem.